Good evening, good afternoon, good morning, whatever it may be for you. My name is Todd Sharp. Thank you for joining me today. Greatly appreciate it. And today we are going to talk about fighting diabetes with technology. To be a little more specific, we're going to talk about calculating insulin with automated carb counting, with a little bit of AI, a little bit of ML, a lot of Java, and a lot of other fun things. So again, thank you for joining me, and let's go ahead and get started. So we're going to look at some really cool stuff today, I think. And to give you a little background and context to this presentation, I'd like to share a little bit of a personal story. Let me tell you a little bit about myself. I live in the beautiful mountains of northern Georgia in the southern United States with my wife of 18 years now, I believe. Yes, I should get that correct. That could be bad to not remember the amount of years. Just 18 years. My 14-year-old daughter and my 13-year-old son. We also have a potbelly pig. We have 12 chickens, 2 dogs, and 1 cat. So yeah, we have quite a lot going on here, but we love it, and this is our life. So let me tell you a little bit about my daughter, Ava. She's pretty much your typical 14-year-old girl for the most part. She's very smart. She's very mature, very organized, all of which she gets from her mother. And she's involved in a lot of activities, chorus, beta club, activities like archery. She can be kind of quiet and shy around new people, but when she's around us, she's really goofy and just kind of fun and just a really good girl. So last spring and into the summer, Ava started experiencing various symptoms that kind of at first didn't really seem like a big deal and did not seem really related to each other. And, all typical things you kind of think of when a teenager is growing. Just being tired all the time, always hungry, always thirsty. So at first, we weren't too concerned. But she started getting like blurry vision and headaches and things like that. And we started to get a little concerned at that point. So it came to a point where my wife was kind of really concerned, and she took her to a doctor, and the doctor did a blood test, and Ava's blood sugar was at a level of 475 milligrams per deciliter, which is much higher than what a normal range would be expected to be. A normal range is usually around 100 milligrams per deciliter. So yeah, she was almost 5 times as much as a normal blood sugar range. So that night, Ava was admitted into the hospital, and they diagnosed her with type 1 diabetes. So we spent the next 3 days in the hospital, really getting her blood sugar levels under control, and then kind of spent the next few months learning how to manage the disease of diabetes. We're really trying to learn as much as we can. It's a constant learning process. You're always going to have to kind of figure things out as you go along. But we're just trying to help Ava learn what it means to be a diabetic, how to listen to what her body's telling her, trying to help her realize that being a diabetic does not define who she is. It's just, and it's nothing that could have been prevented. It's just a challenge that she has to deal with now, and one that we know she can overcome. So what exactly is diabetes? A lot of you have probably heard of it. There may be even some people here that are affected by it in one way or another. But just to clarify things, let's define it. So basically, type 1 diabetes is when it's an autoimmune disease, and it occurs when your pancreas stops producing insulin. And insulin is a hormone that regulates and helps control your blood sugar levels in your body. So type 1 diabetes develops when the insulin producing pancreatic beta cells are they're destroyed by your body. The body mistakenly assumes they're bad and destroys them, and the result is type 1 diabetes. Now, diabetes cannot be cured. Type 1 diabetes cannot be cured, but diabetics can manage the disease through diet, getting exercise, and receiving insulin. Every diabetic is different, but really a typical day in the life of a diabetic might involve monitoring blood sugar throughout the day. Blood glucose, blood sugar, these terms are interchangeable. Now, many diabetics accomplish this through manual finger pricks with a device like this or something similar, where essentially they prick their finger, they put a test strip into the device, and they put the drop of blood on the test strip, and it reports to them what their blood sugar is. Now, this happens at a minimum of 6 times a day for most diabetics, sometimes more, sometimes 10, 12 times a day. They have to prick their finger and test their blood sugar. Diabetics must count carbohydrates at every meal and at most snacks throughout the day. Now, it's very important to be as accurate as possible when doing this because they use this carbohydrate data along with their current blood sugar levels to perform a calculation, and that calculation determines how much insulin they need based on a very personalized formula. A very tricky disease because pretty much every diabetic is different, and how that formula is customized is different for pretty much every diabetic. And this formula not only is it different for every diabetic, it may differ at every meal of the day. Just certain diabetics, are a little more sensitive to insulin at certain times of the day, and so that formula has to be pretty customized. Now, once that amount of insulin is calculated, they administer the insulin through injections. And finally, they have to be aware of and manage unexpected highs and lows throughout the day, right? So depending on many factors, exercise, things like this, your blood sugar could go up or down throughout the day. Could be while they're sleeping, it could go up or down. In fact, just last night, my wife was shouting up to my daughter in her room at about 2 or 3 in the morning to come downstairs and drink a juice and eat a banana because her blood sugar had dropped pretty low while she was sleeping last night. So this routine is a reality for millions of diabetics every single day, without breaks, without cheat days, no matter what, just to stay alive. Thankfully, there is a lot of technology that has really made diabetes management a lot easier. Now, if a diabetic is lucky enough to have insurance here in the US, or lucky enough to be able to afford these kind of things without insurance, oops, I'm sorry, let me back up. They have the option to use things like continuous glucose monitors. Now, what these are tiny little sensors that are inserted just below the skin and held on with an adhesive or like a sticker. And these monitor your blood sugar pretty much all day long. And they are able to share that device with their smart devices so that we could get alerts at 2 in the morning on our smartphone that says, hey, your blood sugar is dropping low. Now, this could be a lifesaver. I mean, this technology is really great. Being able to be alerted to these things when you're sleeping, when it could be crucial, is very great. Insulin pumps. Insulin pumps deliver insulin doses, both constant doses, which are known as basal, or on demand, such as which is called a bolus, via another small tiny tube that's inserted just below the skin. These provide a reliable stream of insulin, and they're more discreet. They're less obvious than a manual needle injection. And they can also be controlled via a smartphone, and the data could also be shared via the cloud. Not to go too deep into it, but there are also things called artificial pancreas systems, and these are becoming more popular, getting more approval from the government and so forth here in the United States. But to really overly simplify things, essentially it's a system of hardware and software, the CGM and the pump, that talk to each other. So instead of the diabetic having to tell it how much insulin it needs based on the reading from the other system, they talk to each other and they kind of manage things so the diabetic can basically go about their life. Now, as amazing as all this technology is, and believe me, like I said, it's very amazing, very helpful, due to cost and other limitations, they're just not available or not feasible for every patient. So what's missing? Well, with or without all of this technology, every diabetic must manually calculate their carbohydrate consumption values and enter that value into an app or a device in order to calculate their insulin dosage. Now, this can be time consuming. It can be error prone. People can make mistakes, enter the wrong value, especially if a diabetic is in one of these low or high states where their mind may not be thinking as clearly as it would be with normal blood sugars. And making a mistake calculating your carbs can lead to an under or overdose, which could lower or raise your blood sugar levels to bad levels. So that's why I decided to build something to simplify the process and increase the accuracy of carb counting. So let's take a look at a demo of the application that I built and see how it works. And then we'll go into some of the technology behind it and how it works. So let's take a look at the application. So here's the application, as you can see on the right side of your screen. This is the main menu. On your left-hand side of the screen, you see just a little camera that I have set up pointing down at my desk. And this shows a fairly typical lunch that a diabetic or my daughter might eat for a day. So we have a sandwich, we have an apple, and then we have some granola cups, little granola snack cookies there. So if you look at the Insulin Helper on the right-hand side of the screen, there are two modes that the app can operate in. And this is a progressive web application. So I'm running it right now on my laptop in standalone mode here, but the app can also work on your smartphone device, your desktop, whatever device, your tablet, whatever device the user has, the application will work as well. So there's two modes. Full mode will perform a complete, basically it's very comprehensive. It allows you to factor in your blood sugar. It allows you to choose your foods and so forth. The quick calculation is just tell me the carbs. I just want to know how many carbs are in this, and I'll take it elsewhere and I'll input that data into another system. So we'll demo it with the full mode, which includes the insulin calculation. And next up, we have four different, well, you have however many formulas that have been defined for a user in the system. In this case, I have breakfast, lunch, dinner, and snack. So you can create as many formulas. As I said, throughout the day, your insulin doses may be different. In this case, I've modeled it with 4 different formulas, and we'll choose lunch. And finally, there's 3 different capture modes. There's the ability to capture via a picture. You can use your voice, or you can use a keyboard if you just want to type in the food that you're eating. So let's start out with picture mode. And when we do that, we get taken to this next screen where our camera is visible here, and we can start taking pictures of our food. So we'll start out here with the apple. And if we bring that somewhat close to the camera here and take a picture and accept that picture, the system is going to go off now and it's going to analyze the picture and try to determine what it is that you're actually eating. And as you can see here, we get presented now with which one of these best describes apple. So it has identified that we're eating an apple. Right off the bat, very easy to use, kind of user-friendly, especially for younger kids and teenagers. It's kind of cool. You can take a picture and it knows exactly what you're eating. So it gives you a list of possible things that contain apple that you could be eating. In this case, it's just a raw apple, so we'll select raw apple. And then it goes off to the USDA and it says, give me a list of all the potential serving sizes for a raw apple. So you can see here, you can choose a cup, you can choose a slice. If we scroll down a little bit, you can see that we see 3 options for sizes. If you're eating a whole apple, 149 grams, 182 grams, and 223 grams. Now, this right here is exactly what I'm talking about when I say it can be very difficult to count carbs in the foods that you're eating, because it's a very subjective thing here. I mean, it's hard to tell with a picture here, but maybe you could see in the size of in the palm of my hand. It's very difficult to judge just exactly how much this apple is. Is this 149 grams? Is this 182 grams? And the difference in that could affect our insulin calculation. So in order to be really accurate, I thought it would be really handy to use a Bluetooth scale to be able to weigh the portion. So if I turn on my scale here, there we go, and put it into pairing mode, the light will start flashing. And I say weigh portion instead. So I come over here and you know what? I'm not sure I got it into pairing mode. Oops, you know what? Let's start over. Think my scale got a little goofy there. So let me try that again really quickly. And hopefully the scale will pair up. I was testing this earlier, and sometimes when you've paired it and you've not unpaired it, it gets a little weird with the Bluetooth connection here. But it's still a really handy way to get a really accurate reading. So if we just give it one more second to analyze this picture. Well, I'll tell you what we're going to do. We are going to restart the application. Sorry about that. Usually don't have any problems with that, but of course, when you're doing a demo, sometimes things get a little weird. And let's get this back pinned to the screen. All right, let's try it again. Full lunch and picture. And we'll turn the scale off while it's doing that. All right. All right, weigh the portion, turn our scale on. The scale does not want to go into pairing mode today, which is not something I've ever had a problem with before. All right, well, since I'm having issues with the scale, I apologize for that. As I said, sometimes the demos go a little weird, but essentially the point being, as I said, sometimes it's difficult to estimate the proper weight. So the Bluetooth scale, when working, provides a way to work around that issue. Now, per my testing earlier before the session, that worked perfectly, of course. I know that this is right around 149 grams, so I'll choose 149 grams. Now it's going to ask us if we'd like to add another food to this meal, because of course, typically you're eating more than one food. Now, this time, we'll take our granola cups and we'll take a picture of that. And hopefully that picture will be clear enough. I had a little light glare on there, which sometimes can affect it. But in this case, it worked perfectly. So in this case, it says we're eating Nature Valley peanut butter chocolate granola cups, which is exactly what this is. We'll choose that first item. And you can see here, it says a serving size is 38 grams, which is, as you can see on the packaging, proper 38 grams. So we'll accept that. And then finally, we'll go ahead and move on to the sandwich, which if we were to take a picture of and try to identify that, it might be really difficult for some kind of AI or any kind of image recognition to really know what kind of sandwich it is. So that's why we have the option to use other things to identify our food. So we're going to use our voice instead this time, and we'll say peanut butter sandwich. Let me try that again. Peanut butter sandwich. So using voice recognition, we're able to just tell the application what it is we're eating. We choose that, and we can say that our serving size is 1 sandwich. So now we've input all of our food to the meal. It's time to move on to the blood sugar measurements. So it's going to ask us this time to check our blood sugar. So if we get our blood glucose monitor and we turn that on and put it into pairing mode, as you can see by the blue light flashing there, and pair that up, we are having Bluetooth issues today. Well, it's in pairing mode, so I'm not sure what's going on here. So we'll skip that. And basically what would happen is the system would pair with the blood glucose monitor. It would read our latest reading. And since I can't proceed further without that reading, I'll just essentially tell you what happens. It's going to retrieve the nutritional information for all of the food, determine the carbs based on our weights and our foods that we input, and then perform our insulin calculation based on the specific formula that we chose up front. Finally, once all that's done, it'll tell us the exact amount of insulin units that need to be injected in order to cover that food and the current blood glucose. And then finally, it will present us with a prediction on the next glucose reading based on some machine learning algorithms that were applied. So let's jump over to the slides and take a look at some of the architecture. I apologize for that demo not working. I'm really not sure what's going on with my Bluetooth on my laptop today. Obviously, it's working because my earbuds are Bluetooth, and I'm wondering if maybe those are interfering with it, but we will move forward. So let's take a look at the architecture. At the heart of the system is the progressive web application. As I said, this can be installed on a laptop, a desktop, or a mobile device. And this PWA is backed by 3 different microservices, all deployed as Docker containers in a Kubernetes cluster within the cloud. The user service is the first service, and this stores information like your target ranges and your profile data in a Oracle DB instance in the cloud, an autonomous database instance. This is a Helidon SE Java microservice that handles persistence via Oracle REST data services. We're going to talk about that a little more in a bit, and I'll tell you what that is. So the next microservice is the formula service, and this is where all the formulas are stored. Originally, this was written in Node.js, and this service handles persistence operations for the user-specific formulas that are used in calculating the insulin dosages. So for this service, I'm sorry? Oh, I think someone's mic got unmuted there, but if you have a question, if you could just please throw it in the chat and we'll get to those at the end. Thank you. So for this service, the data is stored as JSON documents in the autonomous database using something called SODA. So what's SODA? SODA is this set of NoSQL style APIs that lets you create and store JSON documents basically in the database. It allows you to retrieve them and query them, and you don't need to know any SQL. You don't need to know how the documents are stored. It just kind of handles all that for you. The final microservice is the nutrition service. So this one's also powered by Java, but this one uses the Micronaut framework. And for persistence operations, it uses Micronaut data JDBC. So I'm going to talk a little bit about Micronaut data today. If you'd like to learn more about Micronaut data, I do have a session on Thursday here at JCON about Micronaut data, where we go into some really good examples of how to use Micronaut data. But essentially what it is a toolkit that uses AOT compilation to pre-compute all of your queries, and then at runtime it executes them on a really thin, really fast, performant, lightweight runtime layer. So the nutrition service also provides an endpoint for image upload and also interacts with the USDA's Food Data Central API for nutrition information. Now, it's interesting to note through the entire architecture, there's only one manual SQL query used thanks to the things like ORDS, SODA, and Micronaut data. We'll take a look a little bit more about that query later. But for now, let's look at the food identification process in a little more detail. Before we do that, I should note that I have, since the original system was created, I have rewritten both the formula service and the user service, both using Micronaut, one of them using Micronaut data and the other one using Java-based SODA. So the previous service was using Node.js, but there's also a Java-based SODA library. So the system has been rewritten a little bit, and we'll take a look at some of that in a minute here. So how's the food actually identified? Well, it can be tricky, as you can see in my demo, but usually when it works, like every other time when it works, the user can input that food, as I showed you, via photo or voice or keyboard. And depending on which method is chosen, there's a few different things that happen behind the scenes. So if a photo is used for the food identification, it's uploaded to object storage and a cloud event fires, which triggers a serverless function. Now, the serverless function performs calls to a couple different third-party APIs. One of them performs OCR, optical character recognition. So in the case of the granola cups, it pulls the text out of the image that is on the wrapper, for example. And another thing that it uses is just a pure image recognition service. So think of something like TensorFlow that you can train to identify a picture. That's what happens when it's something like an apple. So once it does its image recognition and OCR, it publishes those results to a stream. So think something like Kafka. And the notification service, what it does is it listens to that stream. And when it gets some results in on that stream, it uses servers and events to push that data to the PWA client. This allows us to push that data in real time as soon as that serverless function does its work. We don't have to do any polling. We don't have to do any socket connections. We get those results as quick as possible without any manual intervention back to the front end. So as I said, this provides the front end with any image concepts, what they're called, concepts, or the text that is extracted directly from the image, which is used in the next step. The next step, if everything works great, is to grab the nutrition information. So if an image concept is identified, so in the case of an apple, the concept of apple is identified, but there's no text extracted, so there's no words written on the apple, obviously. The concept with the highest confidence value is used to do a keyword search. So it'll return an array of items. Maybe it will think this is an apple, and it's a little less confident that maybe it's a pear or an orange, for example. But it's usually pretty good, and it usually has a pretty high level of confidence in the proper concept. So once we get that concept with the highest confidence, we perform a query of the USDA's API, and that's going to return that list of potential foods. So in the case of the apple, it returned applesauce, apple chips, fried apples, raw apple. So this is the list that's presented to the user that allows them to choose exactly what the food is based on the USDA's database. If the image did contain text, like in the case of the granola bars, then we use that text as the basis of the search for the USDA API. So the user selects the food, and the detailed nutritional information for that food is retrieved again from the USDA. Let's take a little look at the serverless function and how it does what it does. So the first thing that I mentioned, well, one of the things that I mentioned was it uses image recognition. And to do this, it uses a third-party API called Clarify. Now, certainly I could have created a TensorFlow instance, I could have trained a model and gone through all that work to do this work. And certainly training it further would be, something that we could do. But I thought it would be a little easier and a little faster to use a third-party API. And since I'm not hitting it a ton, there's no charges or anything involved in this. So the first thing that we do in the serverless function is grab the path to the image. Now the cloud event that is passed to the serverless function when it's called contains all this information, and we can construct a proper URL to the path to the image in object storage. The next thing we do is construct an instance of the client, the Clarify client, from their API, and also grab the proper model that we want to use. So there are a series of default models, automotive, people, celebrities, things like this. But obviously, when we're working with food, we want to use a food model. So we grab the built-in food model, the default food model, and we use that. And finally, we call the predict method of the Clarify client in the API. We pass it the model ID, the food model, and we give it an input of the image URL, and it gives us back an array of concepts, as you can see on the last line there. Extracting text is done via the Azure Computer Vision API, and this is done by, again, constructing a client, calling the client's recognized text method, and then finally receiving a text-based response. Let's take a look here. Keep looking at the time here because I think we're getting kind of close on time, but I do have quite a lot to get through here. So the user service originally was using Oracle REST data services. Now, as I said, this is a way to get data in and out using REST instead of JDBC, for example. And I want to show you a quick demo of ORDS. And in order to use ORDS, you have to do some SQL queries in order to set things up. So I have a script here that is going to demonstrate that for us. And what we're going to do is create a simple table, in this case, a simple users table. We're going to call enable schema on the schema and enable object on the object to enable ORDS for this specific table. Next, we create a REST client. We create an OAuth client so we can do proper security on these REST endpoints. And we grant the SQL developer role to that OAuth client. And finally, we're going to get our credentials back. So if I run these all real quick, everything gets set up and we get an output of our credentials. If we come over to Postman and we paste those credentials in to Postman, let me close some things down here. I think my CPU is getting a little crazy on me, and that's why, there we go, that's a little better. All right, so if we send that request, basically what we're doing here is we're calling the OAuth/token endpoint for ORDS, and that gives us back a access token that we can use with our subsequent requests. So from this point, we've set up ORDS for this particular table, and we get a series of endpoints that can be used with different HTTP methods, such as post, put, get, and delete, to manipulate the data on our table. So if we wanted to, for example, create a user, we can pass a JSON representation of that user, and we get back a user with a new ID. So really easy way to do some simple CRUD operations on a table. In this case, if we wanted to update a user, we can do that. If we wanted to get a specific user by an ID, we simply pass the user ID at the end of the user's URL. And we can do all kinds of things. We can get a list of users. There's pagination support. So if you simply add an offset and a limit to your URL, you can get a subset of your items back. And of course, there's a way to delete. So just an example of how I used ORDS in the application to do some really nice and easy persistence operations against the table via HTTP. Really quickly, one of the things I really like to use ORDS for is microcontrollers. So if you're working with any Arduinos or Raspberry Pi, it's a really easy way to get data in and out of your database, especially if you don't have the ability to use a native method to do that. So let's talk about the formula service. As I said, it uses SODA. I told you a little bit about what SODA is earlier. Now, essentially, this is multi-model support in the database, right? So storing JSON documents and collections in a relational system. Many different DBMS offer multi-model support. You can see a list here. Of course, it's not an inclusive list. It's not everything, but Oracle obviously has support for multi-model through SODA. So I have here a save endpoint, which for the formula service calls the save method and the formula service object. I have a model object, obviously just a simple POJO. And then within the service method, as I said, SODA, they have a Java API. So this just uses the SODA Java API to persist this JSON object into the database. You can see here down on line 6 or so, we get an instance of the collection of JSON documents. Then we call insert and get and just pass it the JSON string, and everything is good and persisted in the database. Now, when you look at the table behind this JSON collection and you do a query against it, you'll see that there's a column called JSON document. And within JSON document, you have your JSON document stored as a blob, a binary large object. Now, if you want to visualize that data, you can use the JSON serialize function in Oracle database, and you can visualize that as a string. But the really cool thing is that you also have the ability to use dot notation to actually pull values out of that JSON document. So you can see here, I'm pulling the name out of that JSON document, and it's displayed as a column. You can also do a where clause. You can also include certain elements from the JSON document in your where clause. So in this case, I want all the formulas that have a blood glucose threshold of less than 100, and I'm able to do that through this dot notation. Let's talk quickly about the nutrition service, Micronaut data. I told you a little bit what that is. And essentially to do this, we need to map an entity. So I have an entity, in this case, a meal object, and I just annotate that with mapped entity, and it is Micronaut data picks up on that and says, okay, I need to manage that and create the proper queries at compile time. The next thing you need to do is declare a repository for your persistence operations. And with Micronaut data, a basic repository will typically extend the CRUD repository interface, and this will give us concrete implementations at runtime for the methods listed there. So just having an entity and creating an empty repository interface gives Micronaut data enough information it needs to implement all of these different queries at compile time, calculate them at compile time, and give you the ability to execute them at runtime. As I said, here's an example of my meal repository for this service. Essentially, all I do is have an empty repository here that extends CRUD repository, and at runtime, I've got everything I need to do CRUD operations against that. You can also add additional methods. There's a specific convention that you can follow and do things like find by user ID. We'll talk a little bit more about that on Thursday, so be sure to check out that session. Let's look finally at how the next glucose reading is predicted. I wish I could have showed you this in the demo, but due to my Bluetooth issues, I was unable to get that far. So this uses Oracle machine learning notebooks, and these are Jupyter notebooks that are available against any autonomous database instance in the cloud. and allows you to create basically this machine learning notebook and train data sets and do machine learning operations. So the first thing I do for this particular application is create a materialized view that combines data from all three of those different services. So my formula collection, yes, it's stored as JSON, but as you can see here, I use the JSON table function, and I can get that into a format that can be joined to my user data. It could be joined to my nutrition data, my meal data, and basically just create a materialized view, a big picture view of all that data in three different schemas into one materialized view. Next, I create a model. So here I'm using a linear regression algorithm, and to create my model, I create train and test data sets. The train data set uses a sample 60% from the table, and the test data set uses the remaining values. I make some predictions using with upper and lower bounds against that. And then finally, the one SQL query that's used in the entire application uses the prediction function and the user input values from the current session to make a prediction based on that, that model that we created and trained in the previous steps here. So I believe this application really has the potential to make carbohydrate counting much easier for a lot of diabetics, especially those who are younger or newly diagnosed. Oftentimes caregivers, aunts, uncles, grandmothers, grandfathers that are trying to help you out with your diabetic child, they're a little less familiar with the ins and outs and the everyday things. So anything that gives them an easier time helping your child or your diabetic patient, whoever it may be, anything that gives them an easier time to figure those things out is obviously a good thing. I also want to leave you with this. Everybody here, we all have a very specific and diverse set of talents. And what I really have a passion for is taking those talents, taking those skills, taking those abilities, and using them to make the world a better place. So obviously I created this for my daughter. It's something that I hope someday will help other people. Absolutely hope that someday I can get this out, whether it's open source or whether it's via a commercial product or a free product, whatever it may be. I hope to make the world a better place through my technology. And I encourage you to do the same. Find something that you're really passionate about, something that affects you directly, something that affects someone you love. Maybe it doesn't affect, maybe it affects total strangers. It really doesn't matter, but just take those skills and abilities and use them to do something that will make this world a better place. So thank you very much for having me. Again, apologies for the technical difficulties. Never run into those before, and I'll definitely be trying to figure out what went wrong after the session here. But here is my contact information. My blog is at recursive.codes. You can follow me on Twitter, or connect with me on Twitter, and we can chat some more. I blog a lot at the Oracle Developers blog. There's my email address if you want to connect on LinkedIn. Maybe there's something that you thought of after the session here. Of course, we can get to the Q&A now, but feel free to connect. And again, thank you very much for having me here at JCON. I appreciate it. All right,
so
let me take.
We have a few questions in the chat, or one at least.
Okay.
So are there any similar projects used by the nutrition market already? If not, could this project also be used for other purposes?
Sure. So ironically, when I originally created this last summer and into the fall of last year, and there was, I found out that there was a company, and I can't remember where they were. They were somewhere in Europe. It might have been Germany, who came up with a very similar product to this, with a lot more resources and funding and so on and so forth behind that product. So there are somewhat similar products. I don't think there's anything identical to this, but certainly it's possible. For something, and there are similar apps that provide you with calories and carbohydrate information and other nutritional information, not so much that use the AI and ML like I did, but certainly if there is a potential for that to be used with, with other diet-related diseases, absolutely. And a manual insert of the values should be available. I agree, you're absolutely right. There is the ability to override certain things, but you're probably right that not having to rely on Bluetooth would probably be a much better thing, not only for demos, but sometimes it's not always available. Sometimes Bluetooth is not always available. And in fact, another possibility is if a patient is using a glucose monitor, some of those manufacturers actually have an API to allow you to pull values as well through the API. Of course, that means you'd have to authenticate against that API, and that brings another set of challenges and so forth. But it's another potential option that I've thought of. How much research did you use as you started? Honestly, we did a lot of research when we first learned about the disease. Night and day, obviously spent a lot of time reading up about it. The fact that I am not a healthcare expert, I'm not a healthcare provider, is one of the hesitations in me expanding this application and making it more widespread. Certainly, I want to make sure that it's properly, it's not going to do any damage to anybody, obviously, and it's not going to lead to improper insulin dosages. The last thing I would ever want to do would be to someone to make a mistake or get an improper insulin dosage because of this application. So, I did as a parent, I did a lot of research, and but as far as being a healthcare professional or even a machine learning expert, I'm not a machine learning expert. So, clearly the algorithm that I used might not be the best algorithm that could be used in this situation. So I think there's a lot of potential here. I think, as I said, the company who made a commercial product that is very similar to this, I'm sure has a lot. In fact, I know they have a lot of machine learning experts on their staff. They have a lot of funding behind their application. For me, it was more, I need to do something to help my daughter, and I need to make this easier and more reliable and less error prone. But there's certainly a lot of potential here. And again, as I said, I hope it inspires somebody else, maybe even someone here today, to do something similar and build something similar or contribute to something that means a lot to them. So that those two things, were kind of my motivation and drive behind this project. So I don't see any other questions. Am I missing anything? Mac's device is already paired with the notebook. I think that could be it. Or as I said, I've never tried the demo with my Pixel Buds paired here. So I don't know what it was, but I assure you that I tested this and ran through a demo 2 or 3 times this morning, and many times in the past that I've presented this and never had this problem before. This is the first time that I've used the Pixel Buds while presenting. So maybe I will take that out of the equation next time, and hopefully that will make a better situation. I don't see any other questions. Again, thank you very much, JCON. I really wish we could be together in person for this, but I do thank you for joining me virtually and putting up with some of my technical difficulties. I hope it was useful to you, and I hope you enjoyed it. And thank you so much for coming.